close your eyes and imagine drifting through the vast expanse of space, where silence is not empty, but filled with the whispers of ancient starlight. Tonight, we embark on a gentle journey through the cosmos, a voyage that has captivated humanity's imagination for generations. As you settle into comfort, let your mind wander among the stars, where incredible stories of discovery and wonder await. For over 60 years, brave explorers, both human and robotic, have ventured beyond our pale blue dot, carrying with them our dreams and curiosity. From the first tentative steps into the void to the sophisticated missions that now traverse the solar system, each expedition has revealed new mysteries while answering age-old questions about our place in the universe. Tonight, we'll visit the moon's ancient cratered surface, where Apollo astronauts once walked in the ethereal lunar silence. We'll accompany the Voyager spacecraft on their grand tour of the outer planets, witnessing active volcanoes on distant moons and the ethereal beauty of Saturn's rings. We'll explore the red landscapes of Mars through the eyes of rovers that have become our mechanical ambassadors, searching for signs of life in an alien world. The cosmos is vast beyond comprehension, a tapestry woven from billions of galaxies, each containing billions of stars, many harboring worlds we are only beginning to discover. Yet in this immensity, we find stories of profound beauty, stellar nurseries where new stars are born and brilliant nebulae, ancient, light from the dawn of time still traveling through space, and the dance of celestial bodies that has continued for billions of years. As we drift together through this cosmic narrative, allow the gentle rhythm of discovery to carry you toward peaceful rest. These are not just stories of machines and measurements, but tales of human wonder, of our eternal quest to understand the universe that cradles us. Each mission, each photograph, each data point represents humanity reaching out into the darkness, seeking connection with the infinite. The universe is patient. It has waited 13.8 billion years to tell us these stories. Tonight, as the boundaries between waking and dreaming begin to blur, we become part of that ancient narrative, citizens of the cosmos exploring our celestial home with the wonder of children and the wisdom of ages. Let us begin this journey together, floating gently among the stars. On a quiet July evening in 1969, humanity took its first steps beyond Earth, leaving footprints in the ancient dust of the moon. But this moment was not just the culmination of a single mission. It was the flowering of a dream that had burned in human hearts for millennia. The Apollo program began not with rockets and computers, but with a bold declaration from President Kennedy in 1961 to land humans on the moon and return them safely to Earth before the decade's end. At the time, America had barely 15 minutes of human spaceflight experience. The audacity of the goal seemed almost impossible, yet it ignited a collective imagination that would reshape our understanding of what humans could achieve. Picture, if you will, the Saturn V rocket, a magnificent tower of aluminum and steel rising 363 feet into the Florida sky. This engineering marvel, still the most powerful rocket ever successfully operated, was humanity's chariot to the moon. When it thundered to life, 5 F1 engines produced 7.6 million pounds of thrust, enough to briefly outshine the sun itself. The ground would shake for miles around, and the sound would echo across the landscape like the roar of a mechanical god awakening. The journey to the moon took 3 days. 3 days of gliding through the cosmic void, with Earth gradually shrinking from a world to a blue marble to a pale point of light. Astronauts described looking back at our planet and seeing it whole for the first time, a fragile oasis hanging in the black velvet of space. This perspective, now known as the overview effect, fundamentally changed how we see our place in the universe. The lunar module, a delicate, spider-like craft that would never fly in atmosphere, was humanity's first true spacecraft designed purely for the vacuum of space. When Neil Armstrong and Buzz Aldrin descended to the moon's surface on July 20, 1969, they were piloting a machine that represented the pinnacle of human engineering, yet was controlled by computers less powerful than a modern calculator. That's one small step for man, one giant leap for mankind. Armstrong's words crackled across the 240,000-mile void, reaching Earth 1.3 seconds after he spoke them. In that moment, the boundary between science fiction and reality dissolved forever. Humanity had become a spacefaring species. The moon they explored was a world of magnificent desolation. No atmosphere softened the harsh shadows. No wind stirred the ancient dust. The silence was absolute, broken only by the sound of breathing and heartbeats inside their spacesuits. Yet in this alien landscape, they found profound beauty. The gentle arc of Earth hanging in the star-filled sky, the play of light and shadow across crater rims, the strange sensation of gravity that allowed them to bound across the surface in slow, graceful leaps. Over the course of 6 successful missions, 12 astronauts walked on the moon, spending a total of 80 hours exploring its surface. They collected 842 pounds of lunar samples, rocks and soil that would be studied for decades, revealing the moon's violent birth and ancient history. These samples told a story of cosmic bombardment, of a solar system still forming, of worlds colliding and reshaping themselves in the early days of our cosmic neighborhood. The Apollo program ended in 1972, but its legacy continues to inspire. The technological innovations developed for the moon missions, from miniaturized computers to life support systems, found their way into countless applications that improve life on Earth. More importantly, Apollo showed us that humans could work together to achieve the impossible, that our species' greatest strength lies not in our individual abilities, but in our collective imagination and determination. As we drift deeper into space in our minds tonight, imagine the Apollo astronauts floating in their command module during the quiet hours between Earth and Moon. Through their tiny windows, they saw the infinite cosmos spread out before them, a vista of stars unchanged since the birth of civilization, yet somehow transformed by the simple fact that humans were there to witness it. They carried with them not just the hopes of their nations, but the dreams of every human who had ever looked up at the night sky and wondered what it would be like to touch the face of the moon. The moon still bears those footprints, preserved in the airless environment for potentially millions of years. They are humanity's first permanent mark on another world, a quiet testament to the moment when we learned we were not forever bound to the planet of our birth. As you close your eyes tonight, perhaps you can feel the gentle pull of that ancient companion still dancing with Earth as it has for billions of years, waiting patiently for our return. In the summer of 1977, when disco music filled the airwaves and humanity was celebrating its technological prowess, 2 small spacecraft embarked on what would become the most extraordinary journey in the history of exploration. Voyager 1 and Voyager 2 were not just heading to the outer planets, they were voyaging to the edge of forever, carrying with them the hopes and dreams of an entire species. Voyager 1 and Voyager 2 were not just heading to the outer planet. The mission began with a celestial gift, a rare alignment of the outer planets that occurs only once every 175 years. This cosmic ballet would allow spacecraft to use the gravitational pull of each planet as a sling, accelerating them toward the next destination. The mission began with a celestial gift, a rare alignment of the outer planets that occurs only once every 175 years. This cosmic ballet would allow spacecraft to use the gravity in an intricate dance of orbital mechanics. Mission planners called it the Grand Tour, and it would take humanity farther from home than we'd ever traveled. Picture these twin explorers, each no larger than a compact car, powered by nuclear generators and equipped with golden records containing sounds and images from Earth, a message in a bottle cast into the cosmic ocean. The golden records, curated by a team led by astronomer Carl Sagan, carried the sound of wind and rain, the cry of a newborn, music from around the world, and greetings in dozens of languages. If alien civilizations ever discovered these spacecraft, they would find not just scientific instruments, but a love letter from Earth. Voyager 1 launched on September 5, 1977, followed by Voyager 2 on August 20, a counterintuitive sequence that would allow Voyager 1 to take a faster trajectory. As they departed Earth, they began transmitting data back across the growing void, their signals taking increasingly longer to reach home as the distance expanded at the speed of light. The first destination was Jupiter, the giant of our solar system. When the Voyagers arrived in 1979, they revolutionized our understanding of this gas giant world. The Great Red Spot, a storm larger than Earth itself, revealed its intricate structure. Jupiter's faint ring system, completely unknown before Voyager, appeared in their images like a delicate halo around the planet. But the real revelations came from Jupiter's moons. Io, the innermost of the 4 Galilean satellites, astonished scientists by displaying active volcanoes, the first volcanic activity ever observed beyond Earth. Sulfur eruptions shot hundreds of miles into space, painting the moon's surface in brilliant yellows and oranges. Europa, covered in a smooth shell of ice, showed mysterious cracks and ridges that hinted at a liquid ocean beneath, an ocean that might harbor life. The journey to Saturn revealed even greater wonders. Saturn's rings, long thought to be simple disks of ice and rock, proved to be incredibly complex structures with thousands of individual ringlets, braided patterns, and mysterious spokes rotating around the planet. The rings sang with radio emissions, creating an ethereal symphony that the Voyagers recorded as they passed through the system. Titan, Saturn's largest moon, emerged as one of the most Earth-like bodies in the solar system, with a thick atmosphere and what appeared to be lakes of liquid methane. Enceladus, a small icy moon, displayed geysers of water vapor erupting from its south pole, suggesting another hidden ocean beneath its frozen surface. Voyager 2 continued alone to the ice giants. At Uranus, it discovered a world knocked on its side, rotating like a barrel rolling through space. The planet's bizarre magnetic field and newly discovered rings added to the mystery of this strange world at the edge of the solar system. Neptune, the final planet on the tour, proved to be a world of extremes. Despite receiving only 1,000th of the sunlight that Earth receives, it generated the fastest winds in the solar system, up to 1,200 miles per hour. Triton, Neptune's largest moon, revealed nitrogen geysers erupting from its south pole, creating dark streaks across its pink and blue surface. As the Voyagers completed their planetary encounters, they continued outward, becoming ambassadors from Earth to the galaxy itself. In 1990, as Voyager 1 approached the edge of the solar system, Carl Sagan convinced NASA to turn the spacecraft around and take one final photograph of Earth. From 3.7 billion miles away, our planet appeared as a pale blue dot suspended in a sunbeam, an image that would forever change how we see our place in the cosmos. "This mote of dust suspended in a sunbeam," Sagan wrote, "when every human being who ever lived out their lives." The Voyagers' journey didn't end with their planetary encounters. They continued outward, becoming the first human-made objects to enter interstellar space. In 2012, Voyager 1 crossed the heliopause, the boundary between our solar system and the space between stars. It began transmitting data from the interstellar medium, revealing the cosmic environment that surrounds our solar system. Even now, more than 4 decades after launch, both Voyagers continue to communicate with Earth, their signals taking more than 20 hours to reach us. They travel at about 1 million miles per day, carrying their golden records deeper into the galaxy. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a star in the constellation Camelopardalis. Long after human civilization has passed into history, these spacecraft will continue their eternal voyage, bearing witness to the fact that a species once lived on a small blue planet and had the audacity to reach for the stars. The Voyager missions transformed our understanding of the outer solar system and our place within it. They showed us that the cosmos is stranger and more wonderful than we had imagined, filled with active worlds, hidden oceans, and phenomena that challenge our understanding of physics and chemistry. Most importantly, they demonstrated that exploration is not just about the destinations we reach, but about the journey itself, the act of reaching out into the unknown with curiosity and wonder. As you drift towards sleep tonight, imagine the Voyagers still traveling through the darkness between stars, their golden records spinning silently in the cosmic void. They carry with them the dreams of everyone who ever wondered what lies beyond the edge of our world, eternal testament to the human spirit of exploration and discovery. Mars has captured human imagination for millennia, appearing in our night sky as a red wanderer that seems to pulse with mysterious life. Tonight, we journey to this rust-colored world through the eyes of our robotic ambassadors, machines that have become extensions of human curiosity, rolling across ancient Martian landscapes and showing us a planet both alien and strangely familiar. The story of Mars exploration begins with humanity's eternal question: are we alone? This neighboring world, just close enough to tantalize us with possibilities, has been the subject of countless dreams and stories. When Italian astronomer Giovanni Schiaparelli described uncanali on Mars in 1877, mistranslated as uncanals, he inadvertently sparked a century of speculation about Martian civilization. The first successful visitor to Mars was Mariner 4 in 1965, but it was the Viking missions in 1976 that truly began our intimate relationship with the Red Planet. Twin landers touched down on the Martian surface, their cameras revealing a world of ancient river valleys, massive volcanoes, and polar ice caps. For the first time, we saw Mars not as a distant light in the sky, but as a real world with weather, seasons, and a complex geological history. The modern era of Mars exploration began with a small six-wheeled rover named Sojourner, which rolled off the Pathfinder lander in 1997. No bigger than a microwave oven, this brave little explorer spent 83 days examining rocks and soil, proving that mobile exploration of Mars was possible. Its success paved the way for increasingly sophisticated missions. In 2004, two identical rovers named Spirit and Opportunity landed on opposite sides of Mars, beginning what was planned as 90-day missions. Spirit touched down in Gusev Crater, an ancient lakebed that scientists hoped would reveal evidence of past water activity. Opportunity landed in Meridiani Planum, where orbital observations had detected minerals that form in the presence of water. Both rovers far exceeded their planned lifespans, operating for years instead of months. Spirit, the more adventurous of the two, spent 6 years exploring the Columbia Hills, discovering evidence of ancient hot springs and volcanic activity. When it finally became stuck in soft sand in 2009, it continued operating as a stationary science platform until 2010, when the Martian winter finally silenced its communications. Opportunity, perhaps the most successful robotic explorer ever built, operated for nearly 15 years, covering over 28 miles of Martian terrain. This mechanical geologist examined hundreds of rocks and discovered clear evidence that liquid water once flowed on Mars. It found mineral veins created by water, analyzed ancient meteorites, and even discovered evidence of past environments that could have supported microbial life. The mission came to an emotional end in 2018 when a planet-wide dust storm blocked the sun for months, preventing Opportunity's solar panels from generating power. NASA's final message to the rover was a poignant adaptation of a song lyric: "My battery is low and it's getting dark." When the dust cleared, Opportunity remained silent, its mission complete after transforming our understanding of Mars. In 2012, a new chapter began with the arrival of Curiosity, a rover the size of a small car equipped with a nuclear power source and a suite of sophisticated instruments. Landing in Gale Crater through a dramatic and sky crane maneuver, Curiosity began exploring what appeared to be an ancient lakebed. Its discoveries revolutionized our understanding of Mars' past habitability. Curiosity found evidence that Gale Crater once contained a large lake that existed for millions of years, long enough for life to potentially develop and thrive. The rover detected organic compounds in Martian rocks, the building blocks of life as we know it. It also discovered that Mars' atmosphere contains methane, a gas that on Earth is often associated with biological activity. The latest chapter in Mars exploration began in 2021 with the arrival of Perseverance, the most sophisticated rover ever sent to another planet. Landing in Jezero crater, the site of an ancient river delta, Perseverance carries instruments specifically designed to search for signs of past microbial life. Its mission represents humanity's most direct attempt to answer the age-old question of whether life ever existed on Mars. Perseverance has already made remarkable discoveries. The rover found evidence that Jezero crater was indeed filled with water in the ancient past, with a river delta depositing sediments that could preserve signs of past life. It has collected samples of Martian rock and soil, storing them in titanium tubes that a future mission will retrieve and bring back to Earth for detailed analysis. Accompanying Perseverance is Ingenuity, a small helicopter that became the first aircraft to achieve powered flight on another planet. This technology demonstration has far exceeded its planned mission duration, conducting dozens of flights and serving as a scout for the rover. Ingenuity's success has opened new possibilities for future Mars exploration, showing that aerial vehicles can operate in the thin Martian atmosphere. The red planet revealed through these missions is a world of stunning beauty and complex history. Mars experiences seasons much like Earth, with polar ice caps that grow and shrink with the changing climate. Dust storms can engulf the entire planet, while dust devils dance across the surface like ghostly tornadoes. The planet's two small moons, Phobos and Deimos, race across the Martian sky, with Phobos rising and setting twice in a single Martian day. Perhaps most intriguingly, Mars appears to have once been a very different world. Billions of years ago, it may have had a thicker atmosphere and liquid water flowing on its surface. River valleys, lake beds, and even what appear to be ancient ocean shorelines tell the story of a planet that might once have been habitable. Understanding what happened to Mars's atmosphere and water is crucial for understanding the potential for life on other worlds. The robotic explorers of Mars have shown us that the planet is not a dead world, but a dynamic, evolving system. Seasonal changes create avalanches at the polar caps, recurring slope lineae suggest the possible flow of briny water, and the planet's interior remains geologically active. Mars is a world that continues to surprise us, revealing new mysteries with each mission. As you prepare for sleep tonight, imagine the rovers still active on Mars, working through the Martian night with their nuclear power sources, or waiting patiently for the sun to rise and recharge their solar panels. They are humanity's eyes and hands on another world, extending our presence across the void to touch the face of our planetary neighbor. In their mechanical persistence and curiosity, they embody the best of human nature, our drive to explore, to understand, and to reach beyond our limitations. The red planet waits for us, its ancient secrets slowly yielding to human curiosity. One day, human footprints may join the tracks of our robotic pioneers on the Martian surface. Until then, our mechanical ambassadors continue their patient work, writing the first chapters of humanity's relationship with Mars, one rock sample and one photograph at a time. In the quiet hours before dawn, when the stars shine brightest and the universe feels most intimate, we turn our attention to one of the most profound questions that has ever stirred the human soul. Are there other worlds like Earth? Are we alone, or do countless other planets circle distant suns, perhaps harboring life as diverse and wonderful as our own? The search for exoplanets, worlds orbiting stars other than our sun, represents one of humanity's most ambitious quests. For centuries, we could only imagine what other worlds might exist. Tonight, we explore the remarkable story of how we discovered that our galaxy is filled with planets, many of which might be capable of supporting life. The journey began in 1995 with the discovery of 51 Pegasi b, the first confirmed exoplanet orbiting a sun-like star. This distant world, located 50 light-years away, shattered our assumptions about planetary systems. Unlike the planets in our solar system, 50% Pegasi b was a gas giant orbiting extremely close to its star, completing one orbit in just 4 days. This and hot Jupiter revealed that planetary systems could be far more diverse than we had imagined. The early years of exoplanet discovery were slow and painstaking. Astronomers used the radial velocity method, detecting the tiny wobble that planets cause in their parent star's motion. Each discovery required years of careful observation and analysis. By 2009, fewer than 400 exoplanets had been confirmed, each one a precious addition to our understanding of planetary systems. Then came Kepler, a space telescope that revolutionized our understanding of planetary frequency in the galaxy. Launched in 2009, Kepler stared continuously at a patch of sky containing 150,000 stars, looking for the tiny dimming that occurs when a planet passes in front of its star. This transit method allowed astronomers to detect Earth-sized planets for the first time. The Kepler mission transformed astronomy. Over its 9-year mission, it discovered nearly 2,700 confirmed exoplanets and identified thousands more candidates. The data revealed that planets are incredibly common. Nearly every star in our galaxy hosts at least one planet. The Milky Way contains hundreds of billions of planets, many of them potentially habitable. Among Kepler's most significant discoveries was the existence of super-Earths, rocky planets larger than Earth but smaller than Neptune. These worlds, which don't exist in our solar system, appear to be among the most common types of planets in the galaxy. Some super-Earths orbit within their star's habitable zone, the region where liquid water could exist on a planet's surface. The diversity of exoplanets discovered by Kepler is truly astounding. There are planets with diamond rain, worlds where glass falls sideways in supersonic winds, and planets so close to their stars that their surfaces are molten lava. Some planets orbit binary star systems, experiencing sunrises and sunsets with 2 different colored suns. Others are rogue planets, wandering through interstellar space without any star to call home. One of the most intriguing discoveries was the TRAPPIST-1 system, located 40 light-years away. This system contains 7 Earth-sized planets, 3 of which orbit within the habitable zone. The planets are so close together that if you stood on one, the others would appear larger in the sky than our moon appears from Earth. This system represents one of the best candidates for detailed study in the search for life beyond Earth. The James Webb Space Telescope has opened a new era in exoplanet science. This incredible instrument can analyze the atmospheres of distant worlds, detecting the chemical signatures of water vapor, methane, and other molecules that might indicate the presence of life. In 2023, Webb made headlines by detecting water vapor in the atmosphere of K2-18b, a sub-Neptune exoplanet in the habitable zone of its star. Webb's observations have revealed exoplanets with atmospheres containing carbon dioxide, water vapor, and even clouds. The telescope has also made the first direct image of an exoplanet, capturing light from a world orbiting a young star 111 light-years away. These observations bring us closer to answering the fundamental question of whether Earth-like conditions exist elsewhere in the universe. The search for potentially habitable exoplanets has identified numerous candidates. Proxima Centauri b, orbiting our nearest stellar neighbor, lies within the habitable zone of its red dwarf star. TOI 715b, discovered in 2024, is a super-Earth that receives just the right amount of stellar radiation to potentially support liquid water on its surface. Each discovery adds to our understanding of the conditions necessary for life. Perhaps most remarkably, astronomers have discovered planets that exist in the Goldilocks zone, not too hot, not too cold, but just right for liquid water to exist. These worlds, scattered throughout our galaxy, represent our best hope for finding life beyond Earth. Some may have continents and oceans, seasons and weather patterns, perhaps even the chemical signatures of biological processes. The statistical analysis of Kepler data suggests that there may be as many as 40 billion potentially habitable Earth-sized planets in our galaxy alone. This means that the nearest Earth-like world might be only a few dozen light-years away, close enough that we might someday be able to study it in detail, or even receive signals from any civilizations that might have evolved there. The discovery of exoplanets has profound implications for our understanding of life in the universe. If planets are common, and if life arises readily under the right conditions, then the galaxy might be teeming with biological activity. From microbial life in the subsurface oceans of ice-covered worlds to complex ecosystems on planets with dense atmospheres, the possibilities are endless. As you drift towards sleep tonight, imagine the countless worlds that orbit distant stars. Picture planets with purple skies and orange seas, worlds where auroras dance in methane atmospheres, and planets where the sun never sets on one hemisphere while the other remains in eternal darkness. Each of these worlds represents a unique experiment in planetary formation and evolution, a different answer to the question of what it means to be a planet. The search for exoplanets is ultimately a search for ourselves, an attempt to understand our place in the cosmic story. Every new world discovered expands our concept of what is possible, what is probable, and what is magnificent in the universe. We are no longer confined to dreaming about other worlds. We are discovering them, studying them, and preparing to understand them in ways that previous generations could only imagine. In the gentle darkness of space, countless worlds orbit countless stars, each one a potential home for wonders we have yet to discover. The universe is vast, but human curiosity is infinite, and together they will write the next chapters in the greatest story ever told, the story of exploration, discovery, and the endless human quest to understand our place in the cosmic tapestry. In the depths of our solar system, where sunlight grows dim and the cold of space reigns supreme, lies Jupiter, the giant guardian of our cosmic neighborhood. This magnificent world, with its swirling storms and majestic bands of clouds, holds court over a family of moons that rival the planets themselves in beauty and mystery. Tonight, we visit these distant realms, where alien oceans hide beneath ice shells and volcanic fires paint exotic landscapes in colors never seen on Earth. Jupiter's moons were first discovered over 400 years ago by Galileo Galilei, who turned his simple telescope toward the giant planet and saw 4 points of light dancing around it. These Galilean moons, Io, Europa, Ganymede, and Callisto, shattered the geocentric view of the universe by proving that not all celestial bodies orbit Earth. In that moment, our understanding of the cosmos expanded forever. Let us begin our journey with Io, the innermost of Jupiter's major moons, a world caught in a gravitational tug-of-war that has transformed it into the most volcanically active body in the solar system. Io's surface is painted in brilliant yellows, oranges, and reds, sulfur compounds deposited by hundreds of active volcanoes. These are not gentle Earth-like eruptions, but explosive events that can shoot material hundreds of miles above the surface, creating towering plumes visible from space. The volcanic activity on Io is driven by tidal heating, the constant stretching and squeezing caused by Jupiter's immense gravity and the gravitational pull of its neighboring moons. This cosmic dance generates enough heat to keep Io's interior molten, creating a world where the surface is constantly renewed by volcanic activity. Some of Io's volcanoes are so powerful that they can be seen glowing in the darkness of Jupiter's shadow, like bright jewels against the black of space. Moving outward, we encounter Europa, perhaps the most intriguing moon in our solar system. This ice-covered world, about the size of Earth's moon, harbors one of the most promising environments for life beyond Earth. Beneath Europa's frozen shell lies a vast ocean containing more water than all of Earth's oceans combined. This hidden sea has been liquid for billions of years, kept warm by the same tidal heating that powers Io's volcanoes. Europa's surface tells the story of a dynamic world. The ice shell is crisscrossed with ridges, cracks, and strange formations that suggest the ocean beneath is active and possibly in contact with the surface. Some regions show evidence of chaos terrain, areas where the ice has been broken up and reformed, possibly by plumes of warm water rising from below. These features hint at a world where the boundary between ocean and space is permeable, where organic compounds from the surface might mix with the hidden sea. The possibility of life in Europa's ocean is tantalizing. On Earth, we find life thriving in the deepest ocean trenches, around hydrothermal vents where no sunlight penetrates. Europa's ocean floor likely contains similar vents, heated by the moon's rocky core and enriched with the chemical ingredients necessary for life. If life exists in Europa's dark waters, it might be as diverse and complex as anything found on Earth. Ganymede, the largest moon in our solar system, is a world of contrasts. Larger than the planet Mercury, it possesses its own magnetic field, the only moon known to have this feature. Ganymede's surface is divided into two distinct terrains: ancient, heavily cratered dark regions, and younger, brighter areas marked by grooves and ridges. These features suggest a complex geological history involving both impacts and internal processes. Recent observations have revealed that Ganymede, like Europa, likely harbors a subsurface ocean. This hidden sea, buried beneath multiple layers of ice and rock, represents another potential habitat for life. The interaction between Ganymede's magnetic field and Jupiter's magnetosphere creates auroras at the moon's poles, dancing, lights that mark the boundary between the moon's thin atmosphere and the harsh radiation environment of Jupiter's magnetosphere. Callisto, the outermost of the Galilean moons, is a world that seems frozen in time. Its surface is the most heavily cratered in the solar system, an ancient record of the early bombardment that shaped all the planetary bodies. Yet, even this apparently inactive world may harbor secrets. Some evidence suggests that Callisto too might have a subsurface ocean, though it would be much deeper and more isolated than those of Europa and Ganymede. The gravitational dance of Jupiter's moons creates one of the most elegant phenomena in our solar system: orbital resonance. Io, Europa, and Ganymede are locked in a 4-2-1 resonance, meaning that for every 4 orbits Io completes, Europa completes 2, and Ganymede completes 1. This celestial choreography has persisted for billions of years, maintaining the delicate balance that powers the tidal heating responsible for these moons' geological activity. Beyond the Galilean moons, Jupiter hosts a vast family of smaller satellites. Some, like Amalthea, are shepherd moons that help maintain Jupiter's faint ring system. Others, like the irregular moons in distant orbits, may be captured asteroids or comets that were pulled into Jupiter's gravitational embrace. Each of these smaller worlds adds to the complex dynamics of the Jovian system. The exploration of Jupiter's moons has revealed that the traditional concept of a habitable zone based only on distance from the Sun is too limiting. These moons, far from the Sun's warmth, maintain liquid water through tidal heating and internal processes. They expand our understanding of where life might exist, suggesting that ocean worlds might be common throughout the galaxy. Future missions will delve deeper into the mysteries of Jupiter's moons. The Europa Clipper mission, launched in 2024, will conduct detailed reconnaissance of Europa's ice shell and subsurface ocean. The European Space Agency's JUICE mission will study Ganymede, Europa, and Callisto, providing unprecedented insights into these fascinating worlds. As you settle into sleep tonight, imagine the hidden oceans beneath Europa's ice, where strange currents might carry exotic chemistry through eternal darkness. Picture the volcanic fountains of Io, painting alien landscapes in colors that exist nowhere else in our solar system. Envision Ganymede's magnetic field lines, invisible threads connecting the moon to Jupiter's magnetosphere, creating auroras that dance across ice-covered plains. These moons represent some of the most promising places to search for life beyond Earth. In their hidden oceans and dynamic geology, they offer environments that might harbor organisms as strange and wonderful as anything in science fiction. They remind us that the universe is far more diverse and potentially habitable than we once imagined, and that life might flourish in places we never thought to look. Jupiter's moons are not just distant worlds, they are laboratories for understanding planetary formation, ocean dynamics, and the conditions necessary for life. In their ancient surfaces and hidden depths, they carry the secrets of our solar system's history, and perhaps the key to understanding our place in the cosmic story. As they continue their eternal dance around the giant planet, they inspire us to dream of the day when human explorers might dive through Europa's ice, witness Io's volcanic spectacles, or walk across Ganymede's ancient terrain, bringing the human spirit of exploration to these distant realms. In the outer reaches of our solar system, where the sun appears as merely a bright star and the cold of space permeates everything, orbits one of the most beautiful objects in the cosmos, Saturn, the ring jewel of our celestial neighborhood. Tonight we drift alongside the Cassini spacecraft on its 13-year journey of discovery, witnessing the intricate dance of billions of ice particles that create the most spectacular ring system known to science. Saturn's rings have captivated humanity since Galileo first glimpsed them through his primitive telescope in 1610, though he couldn't quite understand what he was seeing. It wasn't until 1659 that Christian Huygens correctly identified them as a ring system surrounding the planet. For centuries, these rings remained a distant mystery, beautiful but unknowable, like a crown of ice and starlight circling the golden giant. The Cassini mission, launched in 1997, transformed our understanding of Saturn's rings from simple bands of material into a complex dynamic system of incredible beauty and sophistication. For 13 years, this robotic explorer studied the Saturnian system, sending back images and data that revealed the rings to be far more intricate than anyone had imagined. The rings stretch across nearly 300,000 kilometers, 3/4 of the distance from Earth to the Moon, yet they are astonishingly thin, in some places only a few meters thick. Imagine a sheet of paper scaled up to the size of a football field, and you begin to appreciate the delicate proportions of Saturn's rings. They are composed primarily of water ice, ranging from tiny particles no bigger than dust grains to house-sized chunks, all orbiting Saturn in perfect harmony. What appears from Earth as a simple system of concentric rings is actually composed of thousands of individual ringlets, each following its own orbital path. The rings are named with letters in order of their discovery: the bright A and B rings, separated by the Cassini division, the faint C ring, and the extremely tenuous D, E, F, and G rings. Each ring has its own character, its own story written in the language of gravitational dynamics and particle collisions. The F ring, discovered by Pioneer 11 in 1979, proved to be one of the most dynamic and mysterious components of the ring system. This narrow ring, only a few hundred kilometers wide, is shepherded by two small moons, Prometheus and Pandora, which gravitationally sculpt its shape. The F ring displays kinks, braids, and bright clumps that change over time's scales of hours to months, creating a constantly evolving sculpture in ice and stone. Cassini revealed that the rings are not static but alive with activity. When propeller features, caused by embedded moonlets, create gaps and disturbances in the ring material. Spokes, mysterious radial features first discovered by the Voyager spacecraft, appear and disappear in the B ring, possibly caused by electromagnetic forces interacting with microscopic dust particles. The rings also sing. Cassini detected radio emissions from Saturn's magnetosphere interacting with the ring particles, creating eerie sounds that were converted to audio files for human ears. These, and sounds of Saturn, include whistles, chirps, and haunting melodies that seem to emerge from the cosmic dance of charged particles and magnetic fields. One of Cassini's most spectacular discoveries was the source of Saturn's E-ring. This diffuse ring, which extends far beyond the main ring system, is continuously replenished by geysers erupting from the south pole of Enceladus, a small icy moon. These geysers shoot water, ice, and organic compounds hundreds of kilometers into space, creating the material that forms the E-ring and suggesting that Enceladus harbors a subsurface ocean beneath its icy crust. The shepherd moons that help maintain the ring structure are worlds of wonder themselves. Pan, orbiting within the Encke gap in the A-ring, has accumulated ring material around its